There you go.
So I just did all that for nothing again.
All right, I just wanted to make sure because I knew I remembered seeing a little dot thing in the corner that said recording, and then I didn't see it this time.
Yeah,
Well,
same.
we're gonna keep moving on, and maybe I'll just have to try to record this in a separate session.
No
If you
problem.
guys
Thank
have
you.
any questions, you can always reach out, and I'm gonna try to do another session anyway. All right, so let's go to this one here. So we are recording now, and you guys can see the one that says a patient requires normal saline 2,000 mLs at a rate of 165, right?
Yeah.
Okay. So this is asking us how many hours and minutes that the infusion is going to take. And the reason why I'm doing this one is because if you end up with a fraction of an hour and it's asking you what time the infusion is going to end, you have to be able to know how to convert that fraction of an hour into minutes. Okay, so let's look at the first one. The first one, we have 2,000 mLs and it's going at 165. Okay. So in order to figure out how long it's going to take, we're going to take our total volume of 2,000 and we're going to divide that at the rate per hour, which is 165. Okay. And that gave us a total time of 12.12. Okay. So now you have to figure out how many hours and minutes that 12.12 is representative of. So typically, what we'll do is we'll round this to the nearest tenth. Okay. So 12.12 rounded to the nearest tenth would be what?
12.1.
Well,
12.1. So now you would write that as 12 hours, right? Plus 0.1 hour. Okay. And then we're going to convert that now. So the 0.1, in order to convert that to minutes, you have to multiply it by 60. And that gives you 6 minutes. Okay. So now you can add that to your 12 hours. So you have 12 hours and 6 minutes. So if I asked you what time this infusion was going to stop, now you can tell me exactly what time it's going to stop. Okay, let's look at the bottom one and see if you can do that one on your own. This is asking you something different, okay? Anybody still working? Okay, so you should have got 83 for the bottom one, right?
Yes.
Okay, so now we're going to go to a different screen for a second. Okay, so let's say that you have 1,500 mLs and it's running at 97 an hour. It's now 4 p.m. I want you to tell me how many hours this is going to run for. And I want you to tell me what time it's going to stop. And I want you to tell me what time it's going to stop in military time.
Are we rounded to the nearest tenth?
Yes, you're always going to round to the nearest tenth. When did I say you're going to round to the nearest tenth? Think about that.
Can we give an answer?
Yep.
0730.
Okay, good. That's when you got when it would end. And you said it would run for 15 hours
15 hours,
and
30 minutes.
30 minutes. Okay. Anybody not able to get to that? Please put yourself on mute. Anybody not able to get to that?
Miss Loesch, how did you get the 30 minutes?
Okay, so the first thing we did was the 1500 divided by 7, right?
Okay.
I'm sorry, by 97. And that gave me 15.46. Remember, here you have to round this to the nearest tenth. So that would give you 15.5. And then I took my 0.5 times 60 to calculate my minutes.
Oh, okay, got it. Sorry, I didn't do that part.
Okay, because remember we had 15 hours plus 0.5 hours. And then we have to convert that 0.5 hours into minutes. Okay? You with me?
Yes, got it.
I don't understand that. So I understand you till 15.5 plus 60. Then after that, I don't.
Not plus 60.
I mean, times.
When you took the 1500, let me put it back up here. When you took the 1500 and you divided it by the rate, which was 97, that gave you 15.46, blah, blah, blah. Okay? Remember, I said when you do the time, this is 15 hours. Remember, you're going to round this to the nearest tenth. So that's going to be 0.5 hours. Right?
Yes.
$15 hours plus 0.5 hours. Now you have to convert this into minutes. So 0.5 times 60 is 30 minutes. So it's running for 15 hours and 30 minutes. And you're going to add that on to the 4 p.m., which should have gave you 0730, right? Hello?
Yes.
I'm here.
You got it?
Oh God. 15. Okay, 15, sorry. Add 4 is not 7, it's 9.
Excuse me?
You say add this 15 story to 4 p.m., right?
15 hours you're going to add to 4 p.m. What time would that make it in military time? If you started at 4 p.m. today and ran the pump for 15 hours, when would it end?
19.
If you gotta think military time.
First of all, let's just make it simple. If it's 4 p.m. and the pump is running for 15 hours, 4 p.m. now, let's say 12 hours. Start with that. 4 p.m. and 12 hours is going to be what?
Oh, 400?
In standard time. Yes, you're correct. But in standard time from 4 p.m., 12 hours is going to be what? Edith?
Understand that at all. I'm sorry. Can you just send me a lot of these so I can do it?
No. I'm not sending you a lot of this. 4 p.m. and 12 hours is going to be what? If you start at 4 p.m. today and run something for 12 hours, when is it going to end?
16.
Stop it.
AM.
How could
4
it be
a.m.
16?
You say if I start 4 p.m., right? It's gonna run how many hours? 12?
That's what I said. When's it going to
then
end?
okay, if you start 4 p, it's gonna end 4 a.m., which is
Okay, it's going to end at 4 a.m. That was 12 hours. I asked you to go for 15. So if it's 4 a.m. and you need to go for 15 and you already went 12, how many more hours you need to go?
I'm sorry. All right, I got it.
You need
Thank
to go
you.
3 more hours, right?
Yeah.
Okay, it's simple math. Stop thinking so hard. So 4 a.m. in 3 hours is what time?
7.
7 a.m. And how would you write 7 a.m. in military time?
0700.
0700. But it wasn't just 15 hours, right?
Yeah, it was 30 minutes more.
It was
So
15 hours and 30 minutes. So now you're at 7 what?
0730.
There you go.
Thank
I'm
you.
just trying to give you an easy concept to do the math. So if you start at 4 p.m., you should automatically know 12 hours from any number is going to be that number, right? Again, but it's only going to be p.m. or a.m. That's what's going to change, right? So I'm trying to give you a simple concept to remember it. And I'm not sending you guys questions. Remember that. The only thing you're going to get is this PowerPoint. I'm going to give you resources where you can go and find the questions, because I would have to do the same thing you do. Look for them. And I don't have time to keep looking for math questions. I got a lot of stuff to do, so I made you this concept. You also have the other PowerPoint, which I already gave you. I give you practice math and exemplify.
Ms. Lowe, should we get another practice and exemplify before the exam, before the makeup?
You are either today or tomorrow. I'm going to upload more exams. It's probably going to be tomorrow because I've already spent about 8 or 9 hours on this today already, besides the tutoring time.
Thank you.
Thank you, Ms. Osh.
Thank you.
All right, let's go to the next question. Okay, now we're going to try the same thing, okay? So the nurse determines it'll take how many hours for 1 liter to infuse. You have 1,000 milliliters. It's running at 125. How long is it going to take for this to infuse? You can go ahead and give me an answer once you got it for the top one.
8 hours.
Okay, 8 hours. So if it started at, let's say it started at 11 p.m., when is this going to be over at? And give me both times, military and standard. So
7
it
a.m.
started at
0,
11
7
p.m. It's going for 8 hours. When is it going to end?
0700 and 7 a.m.
0, yeah.
Okay, everybody with me on that? Look at the
Yeah.
bottom one. Now, what's this one asking you? You notice how they flip back and forth because that's what they do on the test.
120.
For the rate, so it's 125.
125. Good. All right. Here you go. Here's your practice. Let's see if you can get them right. So this one's asking how many hours it will take for the infusion to complete. It also says round it to the nearest tenth. And then look at the second one. The second one, you're calculating the infusion time. All right. And also, I want it in hours and minutes. So I want it just in hours, and then I want it in hours and minutes. Again, if you have any problems with any of these conversions, they are all on those resources that are going to be in the end of this thing. Registerednurse.com. You can go under military time calculations. You can go to Nurses Labs, has military calculations, dosagehelp.com. Anybody still calculating here? Okay. How'd we do?
Did good.
Great.
Edith, were you
Yes.
able to calculate these?
Yes, I was. Thank you.
Okay, now are you able to tell me in time? Like if I ask you, this started at 11 p.m., when did it end? Are you able to tell me that?
Yeah, but I gotta practice myself later.
Okay.
Thank you.
Everybody's good with this then, right?
No, I'm not good.
Okay, were you struggling still? How'd you do with the top one? Is that the one that's confusing you? Hello? I can't hear you. Hello? All right, I'm going to move on. You're not responding. I don't
Here,
hear you.
it wasn't the center button wasn't working. Where
Okay.
it says calculate the time in hours and minutes, 10.3 hours But how did I get the 18? How do we get the 18 minutes? I don't know why I can't figure that one out.
Okay, so you have to take the fraction of the hour, which is what?
Which was, what was it, 34?
No, the
Or
fraction of the
30?
hour is a 0.3. Look at the bottom. Look on my screen. Can you see the slide on my screen?
Yes.
You see how I break it down there? I put 10 hours plus 0.3 hours.
Okay.
The 0.3 is the fraction of the hour.
Okay.
You have to multiply that times 60 to get your minutes.
Okay, I got it. Thank you.
Okay. Any other questions on this?
I was confused on that too, but I got it. Thanks.
Okay, because good. On the next one, you're going to have to do this. Okay, so look at the next one. I said you started to, we're asking for the completion time, and you've started to administer 3 liters of the D5 at 1300. It's going over 4.3 hours. So you have to figure out what time it stops. So here you're going to have to calculate those minutes. And you have another one in the bottom. So let's see if you can do both of these. Anybody still working? Okay, how we do?
Good.
Got it. Thank you.
Good.
And if you get a different answer than me, make sure you speak up, because sometimes I do the math wrong. Again, I'm up at 4 and 5 o'clock in the morning working on these, so I do make mistakes. I'm not perfect. But that also tells me that you're learning it.
Can we do the second one? I got the first one, but I didn't get the second one.
Miss
Okay.
Loach, I think your second one was off because it's
Okay,
supposed
so
to be
let's look at it. It might
7.2.
be. It might be. So let's look at it. Okay, so on the second one, we had 1,500 mLs. And it was going at 145 an hour. So I got 10.34 hours. And that should round to 10.3. And then we took the 0.3 times, am I on the right one?
No, it was
Oh,
125 and
With the
900
900.
mLs. So
Yeah.
it'd be 7.2.
got it. Let me go to that one. Sorry. Okay, so we got 125 with 900 mLs of fluid left. So that would be 900 divided by 125. So that would be 7.2 hours. And then it would be 7 hours plus 0.2, which would be
18.
12. 0.2 times 60 is 12. So it should be 7 hours and 12 minutes. And then we were at 8:30. So 8:30 and 7 hours is going to be 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 3:30. So it should be 15:30 plus 12, 15:42. Is that what I had?
Yeah.
I get it now. I
Okay.
get it now. I set up the problem wrong. I put the 125 over the 900. I see now. I'm sorry.
Okay. Everybody good here?
Yes.
Yes.
Okay, let's look at this one. This is a drop factor. So what's your formula for that?
You got to
And I
take
got
the board
these
off.
in 3 different formats, guys, because you'll see these written 3 different ways, at least.
Ms. Loach, you got it on the whiteboard.
We can't see the problem.
I'm getting there. I'm getting there. I got to figure out how to reshare. I'm trying to. Okay, back to this one. How we doing now? Can we see it?
Oh, yeah.
Not,
Yes.
there it
Yeah.
is.
Okay. So these are written 3 different ways, guys, because you'll see them in 3 different formats. Okay. So the first one, this is asking you for the flow rate at how many drops per minute. So you know the formula for this is always going to be total volume over total time in minutes times your drop factor. Now you notice on this one, I give you the volume, I give you your time in minutes, and I give you your drop factor. So really here it's just math. Okay. Now let's look at the next one. I just want to show you all 3 formats and then we'll come back and do the math. This one also asks you for a drop factor, okay? But you notice the difference here is your time is in what?
Hours.
Hours, okay? So the first one, your time was in minutes. This one, your time is in hours. And now let's look at the next one. In hours. Now let's look at the next one. This one tells you your volume. It doesn't tell you your time. It doesn't tell you your time. I'm not sure what's happening here. Why am I getting a background noise? Somebody's double recording me or something? All right, this one here, you notice that it gives you a volume. It doesn't give you a time. Instead, it gives you a flow rate. Okay. And then it gives you a drop factor. So you notice that they're all 3 written differently. And there's a different way that you can solve this one versus the other 2. So let's go back and look at the first ones first, and then we'll come back to these ones. And I purposely put all 3 of these on here because you might see them written in a variety of ways, and people seem to get confused when that happens. Okay, so let's look at the first one. So our formula here is total volume over time in minutes times the drop factor. Anybody have a struggle with doing drop factors?
Me.
Yes.
Okay. So let's set up the first one on the whiteboard. Go ahead and take a picture or write down your information. Let me know when you have it down. We good?
Got it.
Got it.
Okay, and let's go to the whiteboard. Okay, so again, it's going to be total volume over total time in minutes times your drop factor, okay? And then it's always going to be a whole number unless the question tells you to do something else. Okay, so here our total volume is going to be whatever has mLs behind it. So that is going to be 50. Our time is already in minutes. And our drop factor is 15. Now, the only time they wouldn't give you the drop factor is if they give you PD drip or if they give you micro drip. And the drop factor is automatically what?
60.
60. Okay. So here you're just going to do the math. Should have got 25. It's already a whole number, so we don't have to do anything with it. Okay, now let's look at the next one. We'll leave the formula there. And I'm going to go back to the screen in case you guys only wrote down the first question. Okay, so again, what is your formula? Your formula is total volume. So what's your volume here?
100.
100 over your time in minutes, which is
50.
and times your drop factor, which is
10.
10. So now you just have to do the math. Let's see if you can do it without me going back to the screen. Okay, good. If you got 20, that was perfect. Okay. And it's always a whole number unless you're instructed to round, because some of these new programs like Kaplan or even on a test on a CJE, it might tell you to round on these. Otherwise, you don't round. I mean, it might tell you to round. Otherwise, it goes to a whole number. But I've seen a couple of these questions where it'll tell you to round to the nearest tenth, not on your dosage calc though, but on a CJE, on a leadership exam, you might see it. Okay, another thing you might see on a leadership or on a nursing exam is the client has allergies. If they have allergies to the medication, you're not calculating the dose unless you want to go to jail. All right, let's look at this one. So now the difference with this question is what?
Time and hours were needed in minutes.
Right, your time is in hours, so you need it in minutes. So it's going to be the same formula though. So your total volume here is what?
1,000.
1,000. Always look for what has the mLs to it. Then your time is in hours, so you got to multiply that times 60, and that's 720 all day. So 1,000 mLs divided by 720 minutes times your drop factor of 15. And what'd you get?
21.
21.
Okay, do the second one on your own. Okay, 31. Is everybody able to get that?
Yes.
Even the people that were struggling?
Yes.
Okay. Now you know the formula, so I'm going to show you one more because this one tends to confuse people. Okay? To be like, Miss Sue, I can't solve this because they didn't give me a time. So whenever you want to calculate time, what do you typically do? You take the total volume and you divide it by the rate, right?
Yes.
Okay, this question is no different, but the thing here is you have a little cheat here, okay, in this question. So if you are going to use the total volume, which I've told you to do, which is 1,000, then you have to determine how many hours that this is going to run for. And if you took 1,000 and divided it by 100, that would tell you 10 hours, right?
Yeah.
And
You
then
gotta
you would
start
have
with
to convert that 10 hours into
10 minutes.
to minutes. So that would be 1,000 divided by 600 times your drop factor, which is 10. Okay. Now, if you don't want to do that extra work, and you can remember this, if it tells you a rate per hour, which this one does, and I'm going to do this one on the whiteboard. Okay, this tells you it's running at 100 mLs per hour. So that means it's running at 100 mLs over 60 minutes, right? Let's go to the whiteboard. Okay, so here we have 1,000 mLs. We already determined that it was running at 100 per hour, and that total it would be 10 hours, okay, or 600 minutes. Because that's what we really need, right? And our drop factor was 10 here. Okay, so when you did that math, what'd you get?
16.6.
Okay, 16.6, which would round up then to 17 drops per minute, right?
Yes.
All right. Now, in the problem, it told you that it was running at 100 mLs per hour, okay, which means it's running at 100 mLs over 60 minutes. So if you actually took that part and just multiplied it times your drop factor, which is 10 there, you get the same answer. So I'm just showing you that because when you see the problem written like this, and we'll do number 2 so that you can understand it, okay? When you see the problem written like that, where if it gives you a volume per hour, you can use that volume and that 60 minutes as your formula. If you can't remember that, or that's too much for you because you need to be more consistent, then just stick to the formula. The problem is people get mixed up and they don't know what numbers to use when the formula is written like that. Okay, so you have to be able to understand what the question's asking for and what you need to put in order to get to that. So let's try the bottom one. Now, the bottom one's the same kind of question, okay? So if you're going to use the 1,500 here, then you have to divide it by the 125 and determine how many hours that it's running for first. Or you can take the cheat, use the 125 over 60, and multiply the 15. And you understand why you can use the 125 over the 60, right? Because it gave you a volume and a time there.
Are we waiting for the answer, Nicole?
Okay, you can put it out there. Anybody still working on this?
I got 31. Oh, 31.25 or 31.
Correct, 31. Okay. On this one, I showed you the cheat way only. Okay. On the bottom, but on the top, I think, oh, I showed you only the cheat way on the top too. But I also put a little note on there for you that, you know, on this question, because it gives you a volume and a time in minutes, you can help use that to solve. What you have to see is that this 125 per hour is equal to 125 over 60 minutes. Anybody struggling with that at all?
I'm not struggling, but I was confused because at first I did the 1500 divided by 125. That's first I
Yeah,
wasn't
and
paying
see,
attention.
that's okay, but that's going to tell you how many hours it's going to run for. So 1500 divided by 125 gives you 12 hours. Now you have to take that 12 multiplied by 60, which would be 720, right?
Oh, yeah.
So then you would have to take the 1500 divided by the 720 and then multiply that times your 15. You still get
That way it
31.
gets longer.
Yeah, it's longer. So, you know, if you need to stick to the true formula so you don't get confused, that's what you do. But in order for you to do that, you have to calculate how much time this is going to run over. Otherwise, you can take the cheat that's in there. It's just, what are you going to remember on the test? Again, you got to practice these. You got to find questions like this and you got to practice it, because they will flip back and forth and you'll see them. I know you already see them flipping back and forth. And sometimes that's why you guys struggle, because when it flips, you don't know what to do now. Now look at this question. All this is asking you is what you're going to set the pump to in mLs per hour. But look how it's written. Okay. So when you're doing mLs per hour on a pump, what do you need? Volume and time, right? And you have that. The problem is they want you to give the answer in mLs per hour, and your time is in what? Minutes. So you have to convert that time. Okay, there's a number of ways you can do that. You can take your 45 and divide it by 60, and that will give you the fraction of an hour, right? Because when you're going from minutes to an hour, you divide. When you're going from hours to minutes, you multiply. So 45 divided by 60 is what?
0.75.
0.75. So you can just take your 180 and divide it by 0.75. Or you can take your 180, divide it by 45, and then multiply the whole thing times 60. Again, what are you going to remember? Because there's two different ways to do it. Let's look at the solution key here so that you can see how I set it up for you, okay? On the first problem here, you can see on the left there, I gave you the total volume of 180. We put it over the fraction of an hour, which is your 45 divided by 60. You can see that over there on the left on the slide. And that gave you 0.75, which is a fraction of an hour. Okay, so now you take your total volume and you're dividing it by your hours. And that tells you it's 240 mLs per hour. Because here, your volume has to be equivalent. Your time has to be in what we're trying to get it to, which is mLs per hour. If your time is in minutes, it has to be converted at some point. So you either convert it first into a fraction of an hour, or you convert it afterwards. So if you look on the right at the alternative method, okay, I had 180 mLs. I divided it by my 45 minutes. Then I multiplied the whole thing by 60 to convert it to an hourly rate. It doesn't matter which one you use, guys. What it matters is what will you remember on the test. Okay, so let's try the one on the bottom. Again, if you look at the one on the bottom, your time is mixed here. It's in hours and minutes. So you can either convert the whole thing into hours or you can convert the whole thing into minutes. You have to do one or the other. Let's see if you can get this one right. And then look at your answer and see if you did it right. Again, if you converted it into hours, you're going to use the solution on the left. If you converted it into minutes, then you would use the solution on the right. So how'd we do with that? Any problems there with those?
I got the second one wrong.
Me too.
Okay, let me make sure I got the second one right. So did you use the 80? Or did you
Yes.
use the 75?
I used a 75.
I used
Okay.
80.
And then remember, you can't keep that number at 2 hours and 45 minutes. You either have to convert it to hours or you have to convert it to minutes. So if you convert it to minutes, then you had to take that 2 hours and convert that to 120 minutes and add that to your 45 for a total of 165 minutes. All right. Or you could have just used the 45 divided by 60 and made it 2.75 hours. Everybody else got this okay?
Yes.
Okay. I got the same answer, so I think mine's right. And you guys that didn't understand it, how are we now? Are you good now?
Yeah.
Okay. So always look at what's next to the number, okay? When you're doing these, you got to find your volume. People make the mistake of using milligrams, and that's going to make it wrong. All right, let's look at these two. Now, these two we already did practice on, so let's see if you can get the right answer for both. Anybody still working? Okay, how'd we do?
Good.
I just
Anybody?
had a question on the second one, Ms.
Yep.
Loesch, only because the other, I rounded it to the nearest tenth because you didn't say whole number, but that was just me. On your other,
Oh, I
yeah,
said it on the answer, but not on the question, right?
you said it on the, yes.
Okay. So for something like that, like I would have taken either answer choice. I don't know what the committee will do, but like I said, most of the ones that I've seen with them, theirs have been correct. Okay. But if we run into a problem like this, we'll have to address it when it happens. I mean, I'll fight for you. If it doesn't tell you what to round it to and it happens like that, I'll definitely fight for you. All right, let's look at these ones. How are we with these ones?
Okay.
Anybody have a problem with either one of these? These are just desired over have. Okay, let's try these ones. So for this one, it's asking you how much is left in the bag. Okay. So you know it's running at 125 and it ran for 5 hours. So you're just going to take your volume per hour and multiply it times the number of hours that it's running. So 125 times the number of hours it's running here is 5. So that means 625 went out of the bag already. You started with 1,000. So now you have to take your 1,000 and subtract that 625. And that gives you 375. Okay, let's see if you can do the second one. And then I'll pull up the answers. Okay, how'd we do?
Fine.
Everybody's good with that one? All right, next one's a little tricky. This one's especially for my OB people. Now, notice this says you're going to set your pump at mLs per hour. Okay. The question is telling you how much you're going to give over 20 minutes. So the first thing you have to do is determine what the rate will be over 20 minutes. And then, since there's 3 20-minute segments in an hour, you would have to multiply that times 3 in order to get your hourly rate. The second one is a little bit easier because this one tells you how much it's going at per hour. So you just have to do the math. So you see the difference? So let's see if we can do the math and get it. Start with the top one. Remember, you're going to calculate how much you're going to give over 20 minutes. And then since you know there's 3 20-minute segments in an hour, you're going to multiply whatever you get there times 3 to equal your hourly rate.
That was a good one.
I gave you an alternative for that too. You could also, since you know you're giving 4 grams every 20 minutes, you could have multiplied that times 3, which would have gave you 12 grams over an hour, and then just put that over what you have on hand. So 2 different ways there to do it for people who may have a different way of setting it up, just so that you understand. Again, you use whatever method works for you. Anybody have a problem with those? Okay, here's another one. See if you can do it. Ah, these are different. What's this one asking you for? And again, you might see these if you're an OB. I still have some other questions for some of you guys that are in the lower classes. So don't jump off yet.
Can you do this one for me? The first one.
Okay. So this is just asking about the loading dose. And the doctor ordered a loading dose of 6 grams over 20 minutes. And you have 30 grams in 1,000 ml. So this is just desired over half. It's just going to be your 6 over your 30 times 1,000.
That's 200.
Right.
It always get to be confusing because of the word.
So we're not doing nothing with the 20 minutes?
Nope.
Okay.
Because what's it say? What's the volume of the loading dose? Again, if it's a dose, what's the formula?
Desired overhead.
So that's
Gotcha.
why you always have to read the last statement, because the last statement
First.
tells you what the author wants here. Whenever
Okay.
you're doing a dose, it's always going to be desired over have. And then go back and look at what do I have in the question. Okay. Do you want me to work that out on the board for you?
Yeah, I do. I do.
Okay, no problem. Okay, so the question says the doctor ordered a loading dose of magnesium sulfate, 6 grams. So here we have an ordered dose of 6 grams. My pen ain't writing well. Okay, and then the pharmacy sent us mag sulfate, and we have 30 grams here times 1,000 mLs. This is just our vehicle. Okay, so now you're just doing the math there. Your 6 divided by 30 times 1,000. They're both in grams, so grams is going to cross out. And that gives us a rate of 200.
Got it. That 20 minutes bothered me a little bit, but I guess that was just fluff, right?
It's not fluff. Like, that's how you're actually going to give it. You're going to give 6 grams every 20 minutes.
It's over. Okay. Oh, every
yeah.
20.
Yeah,
Okay.
6 grams every 20 minutes. Why? Because it's mag sulfate. And so what's this going to do? It's going to lower your blood pressure. It's going to depress your deep tendon reflexes. It's going to do cardiac stuff. So we have to give it, we have to make sure we're giving it over a specific period of time to prevent damage to the body there.
Okay.
So it is important that you know why. Like, it's not really fluff. This is how you would see the order written if you went to the floor.
Okay.
And again, the only thing that would be missing is the nurse was given an order, right? Otherwise, the doctor would write the order, administer a loading dose of mag sulfate 3 grams over 30 minutes. That's how the order would be written. And then you would go to the drawer and you would pull out the mag sulfate and you're like, oh, the pharmacy just sent this. I have 30 grams in 1,000 mLs and I need to give 6 grams over 20 minutes. How am I going to set the pump? So it's not really fluff. This is how you're going to get it. It sounds like it, but it's not. All right. So how about the second one? Are you good to do that one now?
Yeah, I'm good.
Okay. Okay, so those ones are worked out there on the screen for you. Okay, now this one is going to be using the label. Okay. Now, for the label, unless you're reconstituting, all that matters is what is in it. And on this label, you can clearly see you have 10 milligrams per ml, right? You guys see that?
Yes.
Yeah.
Okay. So you have ordered 16, and on hand, you have 10 milligrams per ml. So this is just desired over half. See the math there? Let's try the next one. Okay, see if you can do this one.
$2.4.
Okay, 2.4. All right, and then these you guys can just work on your own. I put a couple of extra questions on here, okay, just to help you remember how to do them. This is another drop factor, okay? So remember, this is like the one that we did earlier. All right, so what are you going to use here to solve this?
$125
and
times divided by the 60 and then times it by 12.
Okay, that's one way you can do it. So do the top and the bottom. The bottom's a little trickier. You got to do some stuff there. We still working? Okay, how'd we do?
Can you do the first one?
Yep.
You're gonna move it out. I just did all that, but them dining rooms doing all that down there.
Please put yourself on mute.
It's
Oh,
the
Lord.
60 times 12 that I don't see where you get that from, Ms. Loesch. The volume
Okay,
is
well, maybe I
1200.
did something wrong, so let's see. Okay, so we had 1,200 mLs.
I
It's
had
going
did
at
her.
125 an hour. And our drop factor is 12. So let's do it the easy way first. I'm going to take the 125 over the 60. Times my drop factor of 12. And I got 25 exactly. And now I'm going to do it the other way, which is the 1,200. I'm going to divide that by 125. And that gave me 9.6. Remember, I have to multiply that times 60 to get my minutes. Which gives me 576 minutes. So now I have 1,200 divided by 576
That's where I've got it. Okay.
times 12.
I was trying to convert the hours and the minutes too early. Yeah, I got it. Thank you.
Okay. Okay. Anybody else with that one or the other one?
Can we do the second one?
All right. So the second one wants drops per minutes and mLs per hour. So I started with my volume, which is 1.25 liters, which is 1.25 liters. Okay, and I multiplied that times 1,000 to get my 1,250 milliliters. So let me do the math while I'm going along, because sometimes I do the math wrong. Times 1,000. Okay, yep, that gave me 1,250 milliliters. Now, it's running over 18 hours, so I divided that times 18. And that gave me 69.4, which is my little milliliters per hour. So I rounded that to 69. Okay. To get the drops per minute, I had to take my 18 here and multiply it times 60. Because that has to be in minutes. So that gave me 1,250 over my 1,080 minutes times my drop factor, which was 12, right? No. 20. So 1,250 divided by 1,080 times 20, which gave me 23.1. Okay. And I rounded it to 23.
Okay, I got 23. I just was
Okay.
confused about the 69.
Okay, because it asked you for both answers, the 69 mLs per hour plus the drops per minute. All right. That's really it for the lesson today. Unless there's something that I did not cover that someone has a specific question on.
Miss Loach, you have any practice with the question where you would give like at the volume and then you would say it's running over like 12 hours and then the other part would say calculate how much you will get the total volume will be in 8 hours.
That's just like the other questions we did. Let me go back and show you. We already did those. And if you learn how to just calculate the volume, then that's all you really need to know. Look at this one here that we did. This question is the same thing. In order for you to answer those questions, okay, you have to determine what the rate is. So if you have 1,000 or you have 850, look at the bottom one.
It's the board. It's the whiteboard I'm seeing now.
All right, let me change it. Where the heck did my Zoom go? I gotta find the Zoom. I can't find the Zoom. Okay, let's try this again. Okay, you see this one here that's on the screen?
Yes.
This is the same as that question that you're talking about. It's the same thing. So in order for you to determine time or volume, you have to have a couple things, right? If you know what the full volume is and you know the rate it's running at, you can determine time. Anytime.
Okay.
If you know the volume, if you know the total volume and you know how much time it's running over, you can determine any rate. So, like, if it said that you had 1,000 mLs and it's going to run over 8 hours, okay, the first thing you got to do is determine the rate.
Mm-hmm.
Okay, so you have 1,000 mLs and it's running over 8 hours. What is your rate per hour?
125.
Okay, now let's say that I said you have 1,000 mLs and it's running over 8 hours. After 5 hours, how much has infused?
So I'm gonna times the 125 because we know that's the rate by 5.
Correct.
Okay. All right.
And that tells you how much has infused. Now, what if it says how much is left in the bag?
Then we subtract.
Right, you're going to subtract whatever you just got there from the bag, which
Okay.
was 1,000.
Okay.
You got it?
Yeah, I think what be throwing me off is when it have the two time hours in it. It would have one that say 12-hour, and then the question is asking you calculate how much will be infused with 8 hours. I get confused after that, but I get it now.
So these are really the same questions. They're just flipped a little bit. If you look at these questions on the screen, this one on the bottom actually is a very similar question to what you're asking about. I know exactly what question you're asking about. And Edith, you should be paying close attention to this one also, because this is what you were asking about. And that's why I purposely put these on here.
Okay.
Okay. Again, you have to really understand what is the question asking me. And I think sometimes you guys miss that. And you answer something different. So remember, my hard, fast rules at the beginning is know what the question is asking you. Okay, because if you don't know that, you're not going to set the problem up right and you're not going to answer it right. So always go to the last statement in the question. Let's just look at a couple for a second. That's not what I want. Let's see if we can find another one. Maybe these aren't the best questions. Let me see if I can find a different spot. Okay, so look at these ones. Like this one says, determine the flow rate in drops per minute. So you have to really ask the question from here. If you go up here and you read the question from here, you're always going to be
It's still on
confused.
rule 1. It's still on rule 1.
Okay, can you see the time-based questions here?
Yes.
Yeah.
Yeah.
Okay, so this is registered nurse, okay?
Yeah.
Lots of practice here. There's lots of free practice here. All you got to do is look for it.
Okay.
But look at each one of these questions because they're different. Like this one asks you, determine the flow rate in drops per minute and what time the infusion would be completed. Always got to start from here, what the question is asking you. If you start from here, you're going to always be confused. Do not start from the top of these questions because you will not know how to answer them. Okay. So this one says determine the flow rate in drops per minute. So the first thing you have to do is set up that formula. Okay. Then it's asking you what time the infusion rate is going to be completed. So in order for you to know that time, what do you need to know?
The time has started.
Great.
You need to know the volume and you need to know the rate. Okay. If you don't have those two things, you can't determine anything else. You have 2,000 mLs here. It's running at 75 an hour. That's going to tell you how long it's going to run for. Again, you have to know what is the question asking me. Look at this one here. This one also says the same thing. So first thing you have to do here is determine the drop factor using that formula. Then you need the volume and the rate. Looks like these ones all ask you pretty much the same thing. Let me copy this and put it in the in with your resources. Because I don't think I have one in there that what happened to my resource page? Let's see. Okay, it's not on this one, but it's on the other one. What is
So
that?
basically number 6, right?
Let's go back to number 6. Go ahead.
The number 6 answer would have been wait. The 17.
So this is asking you how long it's going to take to complete. Okay, so you have 3 liters ordered, which is 3,000, right?
Mm-hmm.
And what's the rate?
175 ml over hour.
Okay, so that's going to take 17.1 hours to infuse. So that's 17 hours, and that 0.1 is 6 minutes, right?
Yes. Times 60.
So really the answer here should be A, because 14 minutes I would think would be too long. But let's see what it says on the bottom. What number was that? 6.
Okay.
So she says 17 hours and 14 minutes. So you know what she did? On my question, I'm going to have you rounded to the nearest tenth. But all she did here was when you take the 3,000 and divide it by 75, you got 17.14285711429, right?
Yes.
So I can almost guarantee you what she did was she took that number and she took off the 17 and she took the 0.142, whatever it is, that whole number, and multiplied it times 60. Or she rounded something there. I don't know what she rounded. Maybe she used 0.143.
Yeah.
0.143 times 60. I still only get, even with that, I still only get 9 minutes. She might have done something else with the drop factor here. Oh, we started it at 8:32. Well, that wouldn't matter. 3,000 divided by 175. Let me do it again.
It gave you 17.14285.
Yeah. So I don't know what she did there because you can only round that to 17.1 or 17.14. That's still only, no matter how I do it, it only gives me 8 minutes. I can't get 14 minutes out of that. I'm not sure what she did there. Again, some of these websites, you know, I have to go with the answer they put up there, and she doesn't explain it here. Let's see another one if we have another one. I'm wondering if so this one is B also. B, I can see that that would be B. If I added, because it started at 10:08 a.m. on number 7.
Mhm.
So 12 hours would be 10:08 p.m. and then 3 hours to that. But I'm not sure where she's getting the extra minutes because that came out exactly to me, unless she's using the drop factor somehow. You're not going to see something like that for me. Okay. So maybe I won't even put this on here because if you do the minutes the way I showed you, you should be able to answer any of our questions right. I'm trying to figure out how she's getting these extra minutes. Let's see if I could see one. So, I mean, for this one, I was able to get 3 hours and 20 minutes. Using the same method I always use. Because with this one here, when you do the 500 divided by the 150, you get to 3.333. And then if you take the 0.3333 and multiply it times 60, you do get the 20. So I'm not sure what she did on those other problems. But if you follow the method that I gave you, you're going to be fine with these. You're not going to get multiple ones like this, okay? If anything, it would be the time and the minutes, and usually we round those minutes to the nearest tenth.
Okay.
Any other questions?
Thank you.
All right, guys. Good luck. Either
Thank
I'm
you,
going to
Ms.
do
Sue.
another dosage calc or Miss Taylor will do one. I'm going to try to do another one. I'm going to try to record this one also, but this one may be recorded in 2 parts. Whatever it is, I'll put it up on YouTube and send you the link once it's done recording.
All right. Thank you.
Thank you.
All right.